In this video, we are going to go through YJC 2010 Paper 1 Question 9b. In this question, we are given a complex number a, which is equals to 1 plus I square root 3. And we are supposed to use the de Moivre's theorem to express the sum of 1 plus a all the way to a to the power of 9 in its Cartesian form. When I first see this question, it straight away reminded me of your complex numbers assignment worksheet, question 16b part 2. When I first attempted that question, I wasn't really able to do it, but then when I look at the solution, I understand the approach to do it. And the approach is to be able to, first of all, simplify the sum by using the sum of GP. If you recognize this is actually a sum of GP, where my first term is equals to 1 and the common ratio is equals to a. So when I take 1 plus a plus all the way to a to the power of 9, by using the formula for sum of GP, I will get first term over 1 minus common ratio, 1 minus common ratio to the power of n, where n is the number of terms. In this case, the total number of terms is 10. Objective is to express this in the Cartesian form, so for the denominator, no issue, I just replace the a by 1 plus I square root 3. But if you look at the numerator, I have this term a to the power of 10. And I look at the question, they actually asked me to use the de Moivre's theorem. So, meaning I should first of all write 1 plus I square root 3 in the exponential form. You'll find that it's 2e to the power of I pi over 3. So this becomes 1 minus 2ei pi over 3 whole thing to the power of 10. And the reason why we want to express that in the exponential form is so as to apply the de Moivre's theorem easily. So this is what I have, and then I get 1 minus 2 to the power of 10 ei 10 pi over 3. ei 10 pi over 3, this is an argument which is outside the principal range. So first of all, I'm going to simplify it by bringing it back into the principal range by subtracting 10 pi over 3 by multiples of 2 pi. In this case, the way to bring it back into the principal range is to subtract it by 4 pi. And so we get 1 over minus I square root 3, 1 minus 2 to the power of 10 ei negative 2 pi over 3. Simplifying, I get 1 over negative I square root 3. 1 minus 2 to the power of 10 is actually 512. And here I get cosine negative 2 pi over 3 plus I sine negative 2 pi over 3. And then we will have 1 over minus I square root 3, 1 minus 512 cosine 2 pi over 3 minus I sine 2 pi over 3. Simplifying, you will get 1 over minus I square root 3, 1 minus 512 cosine 2 pi over 3 is minus half. On the other hand, sine 2 pi over 3 is actually square root 3 over 2. And if you were to simplify this and rationalize the denominator, you will get the answer. But maybe I just want to talk about how to find out what is sine 2 pi over 3 in the exact form. So if you're not sure how to find sine 2 pi over 3, the way I do this is to make use of the MF15. I can write this as sine pi subtract pi over 3. According to MF15, there's a formula for sine A minus B, and this is sine pi cosine pi over 3 minus cosine pi sine pi over 3. But you know that your sine pi is actually 0, so we will end up with minus cosine pi is actually negative 1. Sine pi over 3 is square root 3 over 2. and that's how I find that sine 2 pi over 3 is square root 3 over 2. Knowing this is important when you do trigo questions and you need to express your answer in the exact form. So just to summarize, I think the key thing to doing this question is to know that you have to apply the sum of GP to simplify, as well as to apply your De Moivre's theorem over here. And the need to apply sum of GP is not obvious, but if you have tried your complex numbers assignment worksheet, you know that when you see such a question, that is what you need to do.